Now let's get started with part one by understanding what we mean by the term home network. Now this is a broadly used term that means different things to different industry groups. But in this course, it means the infrastructure, both wired and wireless, used to interconnect products and services to support voice, data, and broadband RF applications, and to connect those products and applications to outside services. Now this covers everything from basic phone service to entertainment to home automation.
New homes should be equipped with the infrastructure necessary to support the following networks: traditional voice telephone service, data networks, broadband RF networks, control networks including automation and security, and audio and video entertainment system networks.
The majority of these networks rely on a structured cabling infrastructure, the communications backbone of the house. And the design and installation of this infrastructure is one of the things we're going to be focusing on this course.
Structured cabling or structured wiring is a relatively new term used to describe a standardized arrangement or structure of cables and devices installed during home construction. These cables are designed to distribute existing and new telecommunications, data, and audio-video applications throughout the home.
The cables originate at a central distribution device, such as this channel vision distribution center, and each cable branches from here to outlets or devices throughout the home. Outlets typically have a combination of jacks to allow maximum flexibility for connecting different devices in the home. All of the outside services, telephone, cable, broadband internet, any satellite or off-air antenna tie into this distribution center, allowing you or the homeowner to select what service is available at what outlet. Now, before we go further, we need to define some of the terms we're going to be using throughout the course, starting with the three B's: baseband, bandwidth, and broadband.
In this course, a broadband network means it supports multiple channels of data or signals at the same time, typically using some form of frequency division multiplexing. It's also used to mean a high data rate, over 1 megabits per second, on a data network. Throughout this course, we'll use the term broadband RF to mean services like cable television, where the cable carries a number of services or channels simultaneously. The bandwidth of a cable, device, or network is the difference between the lowest and highest frequency that it can support without undue attenuation and loss, and is measured in kilohertz or megahertz. For example, cable television channel 2 occupies from 54 to 60 megahertz, or a 6 megahertz bandwidth, while the entire cable service, all 120 channels, occupies over a 770 megahertz bandwidth. A baseband signal means there's only one signal or channel on the network or cable, usually occupying a bandwidth that starts at 0 hertz. The signal has the exclusive use of the cable or network, not shared with other signals. A good example is a baseband video signal, the signal typically available at the video output jack of a VCR or DVD player.
All of the work you'll be doing as part of residential low-voltage installation is covered by codes, standards, and regulations. Standards are typically developed by manufacturers and users in an industry to promote a minimum level of quality and good practices. Now, there are two important Telecommunication Industry Association, or TIA, standards that cover telecommunication cabling in buildings. TIA 568 is for commercial buildings, and TIA 570 is for residential buildings. They address the requirements for cable, hardware, the design, and installation. Now, TIA 570 covers residential, single, and multifamily installations and concerns us directly in this course. The single-family section of 570 covers the specifications for the network interface demarcation point, an auxiliary disconnect, the distribution device and cable cross-connect, the cable and cable installation, outlets and connectors, and equipment cords. Now, outside services are brought to the house and terminate in a network interface device, or an NID, a location or device that defines the termination point for outside networks like cable TV or telephone service. The NID contains a demarcation point where services can be disconnected from in-house wiring. There's also an auxiliary disconnect, where outside services can be disconnected at the distribution device.
Okay, the network interface device, or NID, is the box located on the outside of the house where the local service providers like the telephone company bring and terminate their service. The box is supplied by the local service provider, but you'll provide the cable that you need from here to the distribution device, and we'll show you how to do that later.
Cable service companies also typically use an